Welcome. In this video we'll be solving trigonometric equations involving sine part 3. Let's take a look at our example. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. The equation we have here is 3 plus sine of 2 theta is equal to 2. So the first thing we're going to do is to solve for sine. So we have to subtract 3 from both sides here. And this gives you that sine of 2 theta is equal to negative 1. Now, what we're going to do is to introduce a new variable. Let's call that variable alpha. So let alpha be equal to 2 theta. That way, we can rewrite this in the following form. We can say that sine of 2 theta is equal to negative 1 becomes sine of alpha is equal to negative 1. Now, using the fact that y is equal to r sine of theta, and that since we're dealing with the unit circle, the radius is equal to 1, we get that y is equal to 1 times sine of theta. Or in other words, y is equal to sine of theta. So we're looking for angles that have an actual y coordinate equal to negative 1. So we come here on the unit circle, we say, well, that particular angle that has a y coordinate equal to negative 1 happens to be here. Okay? And that happens when alpha is equal to 3 pi over 2. Now with that in mind, we can now solve for theta. So let's solve for theta. Since we know that alpha is equal to 2 theta, we can say 2 theta is equal to 3 pi over 2. Now solving for theta requires us to divide by 2 on both sides. So let's divide by 2 on both sides of this equation, and we get that theta is equal to 3 pi over 4. So that's one of our solutions. However, since the coefficient of theta was equal to 2, we know that the period of this function is equal to 2 pi over 2. Where is this 2 coming from? That's the coefficient of theta. Now, by dividing here, we get that the period it's equal to pi. So, other possible angles are going to be pi units away from this one. So we can say, well, we take the 3 pi over 4, and we're going to add pi to it. Now, this is equal to 3 pi over 4 plus 4 pi over 4, which will give you 7 pi over 4. So this is also another solution. Therefore, we can say that the solutions to our original equation are simply equal to 3 pi over 4 and 7 pi over 4. Let's see another example here. Example 2. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. Once again, let's isolate the expression with the sign. So to do so, let's add 2 to both sides of the equation. Thus we get 8 times sine of negative 2 theta is equal to negative 4. Now, dividing by 8 on both sides gives us the following equation. We have sine of negative 2 theta is equal to negative 4/8. Now, simplifying this fraction by dividing both numerator and denominator by 4, we get that sine of negative 2 theta is equal to negative 1/2. Now, let's introduce a new variable. So let alpha be equal to negative 2 theta. Why? Well, our ultimate goal is to solve for theta. However, let's simplify this equation by rewriting it with this substitution as follows. Sine of alpha is equal to negative 1/2. Now, using this and the fact that y is equal to r sine of theta, and that we're dealing with the unit circle which has a radius of 1, we have that y is equal to 1 times sine of theta, or simply y equals to sine of theta, we can figure out what is the angle or the angles alpha that will have a y coordinate of negative 1/2. So looking at the unit circle, we find any points that have a y-coordinate of -1/2. So here's a point with the y-coordinate of -1/2, and the reflection across the y-axis works as well. Notice that your angles here happen to be 7 pi over 6 and 11 pi over 6. So we can say here that alpha is equal to 7 pi over 6 or 11 pi over 6. Now, using those values, we can solve for theta. So, using alpha equals 7 pi over 6, let's solve for theta. So we have -2 times theta is equal to 7 pi over 6. Now, dividing by -2 on both sides, we get that theta is equal to 7 pi over -12. However, since this is not an angle on our given constraints of 0 to 2 pi, what we need to do is use the fact that the period of this function, okay, sine of -2 theta, is equal to 2 pi divided by the absolute value of the coefficient of theta, which happens to be the absolute value of -2. So we have that the period is 2 pi over 2, which simply reduces to pi. So what we're going to do is to add pi to this angle theta. So we get that theta could be equal to 7 pi over -12 plus pi. In other words, we have 7 pi over -12 plus 12 pi over 12. Now this becomes simply 5 pi over 12. Now we can try to add another pi in there. So we can say take this previous value of 5 pi over 12 and let's add pi and see if that's still satisfying the constraints that we're given. So this is now 5 pi over 12 plus 12 pi over 12. And notice that this is actually 17 pi over 12. Now we want to be less than 2 pi, and 2 pi is the same as 2 pi times 12 over 12. In other words, this is just equal to 24 pi over 12. So this is still less than 24 pi over 12. However, if we were to add 12 pi over 12 more, notice that you're going to go to 29, which is far beyond the 24 pi over 12, which is equivalent to the 2 pi. So we already have two angles here, 5 pi over 12 and 17 pi over 12. Now let's use the other value that we had for alpha. So now using alpha equal to 11 pi over 6, let's solve for theta. To do so, what we need to do is say, well, alpha happens to be -2 times theta, which is equal to 11 pi over 6. Now, let's divide by -2 on both sides here to get the theta by itself. So we get that theta is equal to 11 pi over -12. Once again, this is not in the boundary of interest because we want theta to be between 0 and 2 pi. So we're going to add the period of pi to it. So theta could be equal to 11 pi over -12 plus pi, which is simply 11 pi over -12 plus 12 pi over 12. Now this simplifies to pi over 12. So that's one of your other angles in there. Now we're going to keep adding pi to it and see if we can find out the other one, since pi is the period of the function. So we have the other angle theta could be equal to pi over 12 plus pi. Now this simplifies to pi over 12 plus 12 pi over 12, since we want the same denominator, which happens to be 13 pi over 12. Now notice that if you were to add another pi, which is 12 pi over 12, you're going to get 25 pi over 12, which is far beyond the 24 pi over 12. Now, with that said, we can say therefore that our solutions are, let's go in increasing order from least to greatest. So we have pi over 12. Then we have the 5 pi over 12. Then we have 13 pi over 12. And lastly, we have 17 pi over 12. So we have 4 solutions for this particular equation. And that's how we conclude this video on solving trigonometric equations using sine part 3. So thank you for watching and have a wonderful day.